Most of my work I do it in Scala for a few years now, and more JS as well, either for client-side stuff or either for small projects where Node.js is a good fit. Even though the keynote speaker was like shitting all over Node.js, it's not that bad a technology. You should give it a try anyway. And in terms of databases, at some point I was like a NoSQL fanboy. And I've tried a few databases, not that much actually, but that's what's funny with NoSQL. You've got lots of choices and lots of trade-offs to make. But in my day-to-day programming life for like normal client stuff, I just use Postgres. It's like a no-brainer for me. And yeah, it's most of my work I do it with Postgres. And I remember when I was like NoSQL fanboy, it was, well, why worry with SQL? It doesn't scale, and it's not efficient. It's not developer friendly. It's too complex, not flexible, stuff like that. And I really like SQL for one simple reason. It's based on something called relational algebra, which is a clean mathematical model, and it's quite rare to have such a good clean model for technology we use. Like the mapping between SQL and relational algebra is very clear, and it's a very like rigorous design, and it's very easy to think in terms of relational algebra. And to me, it's very rational and normal to think in relational terms. Like I have stuff in my head and I draw relations between the stuff I have in my head. So I find it like SQL is very developer friendly because it maps very easily to what I got in my head. But of course, when we want to sell SQL to someone, what we say is that your data will be consistent. It's like the most used argument in favor of SQL is like you've got strong guarantees on your data, and of course it's true. Another thing I really like with that, and something I find it very difficult in document stores, for instance, is to do exploratory queries. Like you got a bunch of data stored in your store, and you just want to extract new knowledge from that. And if you got a document store where everything is already denormalized, it's very difficult to like do cross-reference between different data. In relational stuff, it's very easy because you just do joins, and it's basically done for that. But of course, you rely on one thing. All the good thing in the SQL model is relying on the data model. If your data model is shit, then using SQL will be a pain, of course. So my first point is that you should pay attention to your schema. If you're going to use a relational database, you're using it for its schema, so pay attention to it. And yeah, if you don't care about how it's stored in the DB, then just use a document store on object store. I don't care. But if you want to go through a relational database, then design your schema yourself. Don't let a program use it, because it's the most important piece of your design. And if you let that piece of design to a program, then things will go bad. So it's very central. The schema is like, it draws everything. So don't use ORMs. That's another point. They may be useful in certain cases, and the mapping part is okay. But most of the time, when you want to use it, it's because of operational concerns. It's not about the design of your application. Because the main point was solved ORMs with was, yeah, you can't use any database with that. Like, you shouldn't rely on a specific database engine. And I say bullshit on that. Because if you want to use a relational database, then use it for its strengths. If you want to just drop in a relational engine without actually using it, then just use an object store and get done with it. If you want to use a database, a relational database, then use it for its strengths. And using an ORM and letting an ORM design the schema for you won't let you actually correctly use a relational database. And if you, if you just abandon the false god of DB agnosticism, then just use a good database engine. And Oracle is very good, but if you want to use an open source relational database engine, then right now PostgreSQL is basically the best you can get. So give PostgreSQL a try if you've not done that already. So going back to avoid using ORMs, yeah, basically ORMs are very, very bad, but I'm not saying like write your SQL code yourself and map everything by hand like a caveman. That's not what I'm saying. You can use data mapping libraries. There are lots of them in many different languages. For instance, in Scala, there is a thing called A-norm, which allows you to parse your entities and to like transform a database row into an entity in your code. And it still requires you to write the SQL itself. So yeah, there are wrappers to actually automate the SQL writing. And to write parser, it's very simple. Like you have lots of small parsers, and then you combine them. So you're able, like if you want to do a join query, you take a parser for entity A, a parser for entity B, and you just combine them, and that's all. You don't have to do anything more. Of course, in Scala, there is something called Slick. It's inspired by LinkU in the .NET world. You write just 4 queries, and it will generate the SQL. The idea there, and yeah, in Java, it's a bit more verbose, but in Java anyway. The main idea is that you design the schema yourself and then use abstraction layers to ease your work. And you can be very dry in your code without using an ORM. The main point is that design your schema yourself and then backport the constraints you've made in your schema in your code. When you're using an ORM like Hibernate, you're doing the converse, and it doesn't help you design a good database schema. So design the schema first and then put the constraints in your code. There are lots of interesting libraries to do that easily, so just do that. And there is a very good thing where when you design your queries yourself, is that you're staying in control of the depth. If you have a complex object graph with lots of dependencies, when you design your entities, you're always describing the full tree. Like I have a user, it has like comments, and comments have blog posts which have a user and everything. So you can't always construct the full graph of it because it would be like a huge query. But the object model says it is. So you've got a fully hydrated or partially hydrated tree, which is hydrated based on how you access the data. So what it amounts in practice is that your front-end developer will add a single line of code in a template somewhere, and then the whole query, the whole querying in your database will change because of unclear and implicit depths of fetching. If you do the reverse, like you're always in control of which entity you're getting from the database, then you pass that information to the template. And ORM forces you to do the other thing, like deciding from the template what will be the database queries, which completely violates the layering of your application. And to do that, the best thing I've found, like it comes from experience, is that modeling your data with flat records, like having an object per entity table in the database. And then if I want to get 2 entities at the same time, then I will create a type saying I have a user and a blog post, for instance. But by default, all the entities are flat. And it's your job to actually say when it will be iterated or not with linked information. And it's very good because you're always seeing the costs of fetching the data in the database because it's encoded in your types. It's not encoded in how the object you're returning from the ORM will be called, which functions, methods will be called. And it helps you make joins explicit. So it's encoded in the types, and you have specific methods for that. And you're not like relying on runtime inspection to decide which queries will be made, which is very good because you're able to predict the performance of your application and the load that the database will have. If you let that to the ORM, it will be like runtime stuff, and you will never know what it means, and you will never know if it will change when you change something in a template. Okay. So, now we've got that out of the way, how can we design great schemas? Just a heads up, schema in a database, a relational database, is based off two things. The first thing is entities, which roughly corresponds to objects, and the other thing is relations. It's a relation between entities. So, in a relational database, it's mainly like foreign keys, stuff like that, or in relation tables. Anyway, there is a good theoretical model about how to split your data. It's called normal forms. The first one is like just a definition. It says you've got like every entity has the same fields, more or less, and some of the fields are keys, like primary keys. The second normal form is like saying every non-key field depends on the key field, so it actually gives you the knowledge of having like real key, and the rest depends on the key. And the third form is forcing any non-key field to not depend on a key field. Oh. Anyway, a good level of normalization is the Boy Scout normal form. It's a bit stronger than the third one. It says, like colloquially, you can't have redundancy caused by dependencies between fields. So it says basically your data is like split enough to not being stored twice in the database. If there are relations and dependencies between your data, then you use these dependencies to reconstruct the data. You don't store it twice, which is good because it's easier to update your database for that. That's very good, and I really enjoyed learning about it in school. But in my day-to-day work, it's not that useful. It's good to have it in mind, but it's not that useful. Because what we do when we create a database is like we're just putting data in a way that it's easy to query. And in the end, that's what's important. It's like a user will be query the database and will take data from it. That's what matters. Having like perfect database, spherical in the void, it's good, but it's not what matters. It's not what gives you value. And first thing is that normal forms tell you can't mash several entities into one, but in my day-to-day work, it can be useful. As long as you think about it in terms of how the data will be queried, then composite entities can be a good idea. So you're not always forced to split in several tables. Main idea is that if you're accessing a child entity always through its parent, then you can match the child into the parent, for instance. Or if the number of children is not too big, then updating the whole parent when updating a child won't be any problem, and it will simplify your code a lot. So when you split data into several entities in a database, just always think about how will it be queried, how will it be used by your application. That's very important, and you're able to simplify a lot of stuff with this kind of thinking, especially with things like lists, which are very hard to encode in relational stuff. You can just use an array in the entity, and everything will be like simpler. Another thing is it's not really like high-level design, but having consistent naming is a very good thing. There is a convention on table names is to use singular stuff for different reasons, but the most interesting one to me is that you're already naming your objects with singular or your classes with singular names. So a while ago, I worked in a Ruby on Rails application, and they actually had a separate layer to encode all the exceptions in English, because by default it would just automatically add an S to the table name from the object name. But there was a whole layer saying, oh, the plural of die is dies, the plural of mouse is mice, and stuff like that. And it's completely useless to have this in your application. One good thing is also to name your primary keys and your foreign keys with the same name. It's like self-documenting schema. So you put the name of the table underscore ID, and it's very useful when you're doing join, because the standard way to write a join, like you're selecting from table 1, you declare that you want to join with table 2, and then you put your join condition in an on block. If the primary key and foreign key names happen to be the same, then you can do that. You just using and the field name. It's easier to type. And if there is no ambiguity, you can even do a natural join, and it will do everything for you. Okay, talking about primary keys, please use them. Sorry to just repeat that over and over again, but I've seen tables with no primary key or no index whatsoever too many times, so use primary keys, please. And for the type of the primary keys, I know it's usually an auto-increment ID. Consider using UUIDs. It's universally unique identifiers, and IDs that you can run, you can generate them randomly, and it's good for several reasons. First one is that it prevents entity enumeration. If your primary key is an integer which goes from 1 to 1 to 1, then it's very easy to enumerate the entities in your database. So if you don't have strong access control on this, then you allow an attacker to go through every entity one by one, which can be a big problem. Like there was a website for a TV series, the whole user base was spammed by a direct message, because the spammer just took account with ID 1 and then 2, and then he DM'd the whole user base because the ID was in auto increment. Another thing is that it discloses information about your database, because roughly, not exactly, but roughly, the last inserted ID in your table is roughly the size of the table, or the number of rows in that table. So it discloses, like if it's your user base, it can disclose the number of users you got. Or even though it can be obfuscated with offsets and stuff like that, but it still gives information about how fast your database is growing. And it may not be a security concern, but it's definitely a business concern. And you really don't want to let everyone know how many users you got, or not in the general case. And the last one, which is quite not that good, but since I regularly make mistakes, it's useful. It's like the IDs, they are unique across the universe. So if you put in the wrong table name in a query, let's say a delete query, then there will be no entity with the same UUID in another table. With auto-increment IDs, then it starts from 1 and it goes up from 1 to 1. So it will definitely, yeah? Not in PostgreSQL. They are stored really as 128 bytes. So it's not stored as string. I can talk about it later if you want to. I've written an article explaining in a bit more detail why I use UUIDs. I can talk about it later. And yeah, and they prevent you, like if you make a mistake in the table name with an auto-increment ID, then it will happily delete an entity in another table. And if you're foolish enough to have undelete cascade, then with just a simple typo, you can like wipe out the half of your database. With UUIDs, then it will say there is no entity with that ID, whatever. Also, SQL is nice because it allows you to actually say this value can't be null, which is way better than, let's say, Java, which cannot let you do that, or even Scala. So default, when you're designing your fields, like default to not null, and then think about it. Will it be null at some point? Is it really necessary? Then remove the not null constraint. But your default, the default in your mind should be not null. You've got the choice of, like, the possibility of annotating not null, so please use it, and it should be the default. Nullable stuff shouldn't be the default. This one is for people coming especially from the MySQL world, where the join engine, the join algorithm for tables is notoriously inefficient. So people in the MySQL world are always afraid of doing joins because it won't be efficient and stuff like that. In PostgreSQL, the join algorithm is very efficient, so of course at some point it will cause problem, but you shouldn't design your system around the fear of doing joins. So use joins. You're using a relational database, so you're there to do joins anyway. And last thing, avoiding deletions is a good thing. Basically, since your data is very linked in a relational database, if you got lots of foreign keys, then if you delete one entity, somehow you can be forced to delete the whole dependency graph, which is maybe not what you want to do. So with that, basically, the easiest way to do that is to add a deleted that field with a timestamp, which is nullable. By default, it's null. And when you delete the entity, then you set the deletion time. And you act accordingly in your code. The idea is that you don't always want to delete data. You don't want to lose data. You want to mark it unavailable. That's OK. But deleting a whole chunk of data in your database can pose lots of problems. Especially because of relationships and foreign keys constraints. Main idea is to have your schema done in a way that invalid states and invalid data is not constructible in your database. There should be no way of putting invalid data in your database. So the database has a job to ensure that your data works. And for that, especially Postgres, you can use like very rich type or very precise types. The idea is that the type you're using should be able to represent what you want and not much. And the prime example of that is integers used as flags or as enums. Stop doing that. Either you got a code which should be able to handle 4 billion different cases, and in that case, please stop programming. Or your code is actually handling a lot less of possibilities, and just use enums. It's very cool. You declare your type, and then what goes into an enum. And you're saving space, and you're reducing a lot the number of invalid sheets you can put in your database. Because if you have an enums with 3 things, and at some point you got an entity with like 400 in that, and you don't know what it is. I've worked a lot on rewriting stuff, moving from one platform to another, and every time we had to like move the contents of the previous database into the new one, and every time there was data that didn't make sense according to the code, according to the comments, according to the field names. So if you put constraints directly in your data, it's way better. And I'll go even as far as say, use enums even where there are 2 possible states. And do that in your code too. If you Google Boolean blindness, there is an article explaining exactly why Booleans are a very bad thing. Basically, a Boolean can come from anywhere. If you've got an enum with 2 states, then you have to construct one of its states explicitly. You can't just get a Boolean from anywhere. So you're forced to actually think about what you do when you construct values. Going back to using precise types. How do you store IP addresses in your databases? No? No idea? I used to use varchar 15. Like you've got 4 blocks of 3 characters plus 3 points. I think everyone used to do that at some point, especially in the PHP community. So, you know this guy? It's Christopher Poole, called aka Moot, aka the creator of 4chan, and he was elected the Man of the Year on time because the voting algorithm stored IP addresses in varchar 15. And a guy from 4chan realized that, hey, my server is on IPv6, so I can just vote anytime I want. It won't be recorded, or the fact that I've voted won't be recorded, but the vote will be recorded. So the first choice was him, and then the 15 following choices were creating an acronym, saying like some 4chan shit, which I don't understand, but the idea is that because of improper data stuff, they were able to like completely break the voting algorithm. And what's terrible with that, it's both too restrictive and not enough restrictive. It's too restrictive because you can't encode IPv6 addresses in that, and it's also excruciatingly not restrictive enough because it will accept any string with like any character, which is not restrictive enough because like an IP address is just a bunch of bits, not more. So with Postgres, the good news is that there is a type called inet, which will store efficiently the IP address, just the bits needed to encode the IP address, both IPv4 and IPv6 addresses. And then you will be able to like compute stuff on IP addresses, like masked, stuff like that. Stuff you can't do with strings. Either you're like some kind of regex wire, but yeah. Anyway, there are also a lot of very, very interesting types. Timestamp with time zone actually encodes it in UTC and stores the time zone, which saves a huge pile of problems. A number of databases where the time is stored as an integer, I can only assume is the number of seconds from the 1st of January in 1970, because that's what usually is. But sometimes it's not the number of seconds, it's the number of milliseconds, and sometimes it's the number of days since the 1st of January in 1900. Who knows? If it's an integer, then you don't know. And then you got the problem with time zone, which is like another huge pile of shit. So with that, you're just solving like most of your problems. You can use points, which is nice if you like want to store geographical positions. And you can store time ranges saying, this is an interval of time starting at this date and stopping at this date. Then you can actually say that in one value. And also, you can say, this is an interval of time lasting 10 seconds. The number of times I've seen in a database schema a field called duration with an integer, and is it milliseconds? Is it seconds? Is it days? I have no clue. With interval, you're saying this is a time, and PostgreSQL will handle the units. So if it's a big interval, it will be able to display it in hours or days or months. And if it's a small interval, it can display seconds. But it's not your job to do the conversion. And you can even create your own types. Like if you want to mash a few data together, you just put the fields. I don't know if there is like a complex type in PostgreSQL, but that would be a good way to do that. You just put the real and imaginary values together, and then you've got your complex type. And types are good, but they don't solve all your problems, sadly. So you got constraints for constraining the rest stuff you can't encode in types. And the good thing with powerful types is that you get very powerful constraints. For instance, going back to the time range, you can actually say, this is from real code, I have a bunch of reservations, and I don't want overlapping reservations. And it's just the last line. Say exclude dates with overlapping. And then it's done. Think about the amount of client code you would need to actually make sure it works. This nugget saved me hours, even days of work. It's very, very nice. You can use arrays as well, since encoding lists in relational is very complicated, because like you create a new table for every object in the list, and then you're forced to encode order in your list, and then you have a field containing a counter saying, oh, that's the first element, and then sometimes, oh, where is the fourth element? I don't know. And sometimes somebody came and like put 4 million in some field, and you don't really know why. And it's in the database, so whatever. You can just use arrays, and it will work quite well. It really will reduce the number of tables, and it will be way easier to manage from a code. You can also store key value. With HStore, it's like a simple key value with strings. You got your key, you got your values, which is nice. You can also store JSON, which is very, very nice. Basically, you just give it JSON, and then you can actually store it. You can see the value of a field and stuff like that. And it's stored in binary, so it's very performant. You're able to index it. And I've seen benchmarks. I know benchmarks are always lying, but I've seen benchmark showing that Postgres with JSONB was actually faster than Mongo for JSON stuff, which is not that bad. And yeah, using JSON in relational store, it's usually giving shivers down your spine, but it's actually very useful for some stuff. First one is that you've got a mostly relational data model, and then you're getting data from external APIs, like issuing a call through the SoundCloud or Spotify API, and then you get a bunch of JSON. Then you can just store this into your database, and you just keep the data for later. That's all you need. You can extract interesting values, but you can actually store the raw data into a JSON field, and then you just got it, and you will be able to use it afterwards if you need to. It's also very useful when structuring your results. Do you know ArrayAg? It's very nice. When you're doing a one-to-many join, usually the one part is duplicated. Like you've got one row for every entity from the right, and the entity from the left is duplicated. So at some point in your passing code, in your application, you're saying, yeah, just throw away this bunch of data. Since I wrote the SQL, I know this data will be duplicated, and I know I won't need it, which is terrible. If you think about it, you're just getting a bunch of useless data, and based on like somewhere else in the code, you say that, yeah, I can throw it out, which is not a good thing to do. With ArrayHack, you can actually get one line per entity from the left and get an array of entities from the right. So you don't have to manually group the data from the result. SQL already knows how your data should be grouped, so you just ask him to aggregate on an array, and that's all. You're not like using information, losing it, and reusing it again. You just put the information at first and then use correctly structured data, which is a good thing. And yeah, and with JSON, what we can do is that you're able to group data. For instance, let's say you have a one-to-one join with like an article and an author. If you do a regular join, it will give you a huge line with a mixed field from one entity and the other. With JSON, you can say, give me two JSON objects, one containing the article and one containing the author, which can simplify a lot your code, especially if you're working with, God forbid, Node.js. Then you got correctly structured data directly from the database. You don't have to reuse information you already gave to the database to parse your data. And you can go like full retard on that. You can like put everything in a huge JSON array. I actually do that in production from one simple reason. JDBC is not very good, and it's not able to understand half of what PostgreSQL is able to do. Namely, using arrays with JDBC, not that good. I wanted to go in the code and patch it, and it's like stateful code everywhere. Well, that was terrible. So I spent 10 minutes transforming my results to JSON before having them out from the database, and now it works. Yeah, I'm both proud and terribly ashamed of that, but if you're using a restrictive DB driver, then exporting everything to JSON can be a good solution and can allow you to actually use your database, because not using your database properly just because of JDBC is like a bit sad. Also, if you're using MySQL, you may not know that. After all, it was defined in SQL 99, so just 16 years ago, not that much. It's called common table expressions. It allows you to define subqueries and then reuse them as tables in your main query. So what it gives you is it gives you just modularity in your queries. And since you can do recursive common table expressions, you can have Turing complete SQL, which is not that good, but it's good to know that you can do that. And now, basically for very big queries, being able to name subqueries and everything, it's very, very useful. For modularity, it's very, very nice. And yeah, it was only defined in SQL 99, so maybe MySQL will get it one day. Just wait 16 more years. Okay, now it's the time for shameless plug for something called JDBT. JDBT is a simple program that helps you design databases. The idea is that you write a YAML file with your schema, or at least important information of your schema, and then the program is able to derive SQL schema creation stuff, nice graphs made with GraphViz for documentation. Also in a branch that I didn't want to share, it can generate Scala code to generate entities. So the idea is always to generate stuff from the schema and not generate a schema from the code always. Just remember that. That's the most important thing. So I want to define an enum, then I just define an array in YAML. I want to define an entity, then I define it. It's an entity, so I will need a primary key called member ID. So it's always the same. I don't have to write it down. I will automatically have a member ID key, which will be a primary key. I can put default values. I can put unique constraints. Of course, by default, every field is not null, because it should be the default. And then with extra cryptic syntax, you can say, this is nullable, this is nullable indexed, and everything. So it's very useful when designing your schema. You just write down a very terse YAML file, and then everything is iterated from that. You can put constraints, stuff like that. You can actually overwrite everything, convention over configuration, stuff like that. And then you get like nice graphs. It's very useful. And yeah, code generation to bootstrap a project. It's I don't really like it, but it comes in very handy at some point. So I can live with that. It's also available as an API, so you just post your YAML file and then you get back your results. Okay, to sum up, the most important thing is to acknowledge there is a boundary between your application and your DB. And using a full-blown ORM, what it trains you to do is to be oblivious about that boundary, which is a terrible thing. And all the terrible things, especially in some bloated areas of the Java community, is that somebody wanted to well, let's say that problem doesn't exist. Let's say it's a huge, it's just Java and the rest is automatically generated. Like GUID is the same thing. If you want to hide the fact that there are HTTP calls between your client and your server, then you will run into problems. You can't just hide an untyped network boundary. It doesn't make sense. So acknowledge that boundary and design your schema yourself. And when you design your schema, always think about how it will be queried. That's the most important thing. The database is there to present data, and it's there to get queries. If you design it without thinking about how the data will be used, then why do you even bother designing databases? Whatever. And it helps you a lot avoiding overthinking stuff. If you got linked entities that's always queried together, then just mash them together and just don't add five different tables for nothing, basically. Avoid your arms if you can. I'm always a bit afraid of giving this advice at Java conferences. Basically, people always get angry about it. But you can use an ORM. The idea is that design your schema yourself, and if you want to go through the pain of telling your ORM how the schema is designed, then okay, that's okay with me. You still will have problem with queries being cached, transaction being rolled back transparently, shit like that. You will have problems. I'm working on a GPA project, and it's like GPA has been consistently a pain in the ass every single time. I still don't know what it brought to the project except pain. But anyways, that's just me. If you don't use an ORM, then you're able to use precise types, because if you want to use precise types with an ORM, these types need to be encoded in the ORM, or you got to do that yourself, and it's complicated. With PostgreSQL, the type system is extensible, and out of the box, it provides you so many interesting types. Just look at the documentation for date and time, for instance. It's like magical. Anyway. And linked to designing with querying in mind, you can denormalize, you can duplicate data. do it responsibly. Use your batch judgment and everything, but you can do that. It's not a problem. Always think practically about your database schema, and things will be okay. Thank you for your attention and lack of projectiles. And if you want to give Clever Cloud a try, there is this coupon DevOxPL Rocks. It will give you 15 euros free for trying. Thank you.
Thank you.
And we have lots of time for questions. Yeah.
Sometimes ago, I read an article which suggested that using enums is anti-pattern, that we should design additional table and use foreign keys for it. I'm not sure if it is a good idea, but what you would say?
Okay, so the question is about either using enums in your database or adding an additional layer of configuration with a table. My answer will be depends. If your workflow, if by examining your workflow, you see that it will never change, or if it changes every like 3 years, then adding a new value in your enum, it's not that complicated. And in PostgreSQL, it's not costly to add new values to an enum. So you won't have to rewrite everything. So in that case, it's okay. If it's like typing a new SQL line every 3 years, then that's okay. If it has to be changed without prior notice by the business department, then by all means, go through the pain of designing an additional layer of indirection. And that's also what I mean when I'm saying design with querying in mind. That's typically a thing. Like, if it won't change, then use an enum. Your code will be simpler. You will have less exceptions to manage, and it will just work better. If there is an actual need, then there is an actual need, and use a table. But it really depends on how you're using your database. So definite statements like never use enums, I think they are actually harmful.
Okay, I have a question about rich types.
Yeah.
For example, we will follow your advice. We won't use ORMs. We will use just plain SQLs in our code. And we will use rich types, which are vendor specifics. For example, I know some date range type are specific for PostgreSQL, for example. And what will happen if we will thinking about migrating from PostgreSQL to some other database?
Yeah, that's okay. The idea is about saying that being tied to a database is a problem. When I'm using Postgres, I'm using Postgres, and I've chosen Postgres specifically for its range types. For instance, our projects relying on the fact they exist. So if I want to go from Postgres to MySQL, then I know I'm losing. I chose Postgres specifically for its features. So if you want your database to be so stupid, it can be any database, and then just use an object store. It's made for that. If you're using a relational database, then actually use it for its strengths. And trying to be database agnostic is like, okay, I want to switch database in the lifetime of my projects. Why? Yeah?
Yeah, it happened to our customer. They used a database which they used its specific features.
Yeah.
And then the database was bought by another company.
It was FoundationDB, or?
Sorry?
It was FoundationDB?
No, it wasn't.
Okay.
And the company increased dramatically the license fees.
Yeah.
And now there is a big migration project because of it.
Yeah. I'm talking about open source database, which have been around for some time. That's why I advocate using Postgres. I know it's always a problem. If you want to change your data store, then it will be a problem. But in my experience and in I've seen lots of projects because I was contractor. I was like hopping from project to project. The upfront cost of being database agnostic would kill the benefits of doing the project in the first time. Yeah, it can be a problem, but in like a made-up huge percentage of cases, that's not an issue you want to have. It's like you ain't gonna need it. So it's always about doing trade-offs. I use Postgres because, for instance, the reservation stuff, the client was on a budget. And I was able to use Postgres to deliver value to my customer on a budget. And yeah, if she wants to go to MySQL for at some point, yeah, but the project was designed with constraints. And the constraint of being able to switch from that one database to another is extremely costly in terms of development and in terms of operations. Because when you encode rich types into an inferior database, then you will have lots of problems of data inconsistency, of performance, of stuff like that. So yeah, it can be a problem, but do you want to solve this problem right now? Because it will cost you a lot. I'm not saying that the problem doesn't exist. I'm saying that most of the time it's just not a problem you have the resources to care about correctly. Yeah.
I would like to ask about UUIDs,
Yeah.
because I have seen there is a type for in PostgreSQL. I'm
Yeah.
not. I don't know this database too much, but if there is a type such, is there a mechanism to generate those random UUIDs that would be unique inside of one table?
They are unique across the universe. The good thing about UUIDs is like you're not forced to let the database generate them. You can in Postgres, there are two extensions. One is OSSP UID, and the other one is PG Crypto, which allows you to generate stuff. But one strength of random UIDs is that you just generate a random one using a standard algorithm, which is implemented in every language. By construction, you have a statistical guarantee that it's unique, like the risk of collision after generating billions of UUIDs is still less than getting hit on the head by a meteorite, for instance. And you can generate them in the DB, but the good thing is that you can generate them from your client code. So you don't have to talk to the database to have a complete entity. If you have an entity graph, which entities depending on one another, then you're able to generate your entity graph without ever talking to the database, stuff like that. So it's not complicated to generate them in the database, but it's generally not what you want.
One more thing about this unique ID. So if I would use this as a primary key instead of sequence, because the sequence is a normal way to do it. So I am unable anymore to, for example, generate 4,000 of inserts with this auto-generated UID ID. Because with sequence, I would simply put sequence.nextval. Yes, and so it's not possible.
You can put instead of saying sequence.nextval, you just put generate UID. You will have a performance cost of inserting a lot of UIDs for one reason, is that it's random, so the index will be a bit more scattered. In practice, this performance cost is really outbalanced by all the simplicity it gives to your code, the insurance about security, because when you have a primary key, you can always be sure that it will be exposed at some point, which is a problem. UIDs are not the best technical solution ever for every problem, but they're a definite good use case. So you can generate a bunch of UIDs using generate UID. It's not a problem. The database can generate it for you.
So it is possible to do something like sequence text val just to force Postgres to generate this UID. Yes.
You don't. It doesn't make sense to force. If the UID is not used and it's not used, and it's the same that it doesn't exist. The fact that by construction it's unique, universally unique. It doesn't make sense to force anyone to construct them. It's like you get one and you've got a statistical guarantee that it will be unique. You don't have to. You can generate in Postgres or elsewhere. It's not a problem. I actually wrote a full article about UUIDs. I don't have internet, but if you Google why auto-increment is a terrible ID, not my choice of naming. We needed clickbait, sorry. You Google why auto-increment is a terrible ID, you will find the blog post, and I delve into more details about when UIDs are a good ID and when they're not. And sometimes they're not. It's just in the particular case where you design, like, let's say, web application with moderate to high traffic, then UIDs are a good default because it will simplify your code. It will just make some security issues disappear and everything. You can handle all these problems separately with other solutions, but it will be more costly in terms of code and in terms of the confidence you have in your code. So that's a trade-off otherwise. When you're using databases, it's always about trade-offs.